header, and then is known as function star. And welcome to my first Touchdesigner release / tutorial. We're going to take a look at a complex uvmath toolkit that I developed. It consists of 2+1 modular components, the two being the ComplexOp and the ComplexMix. With the ComplexOp, you can choose from a bunch of different complex functions and generate UV maps based on them. It has a lot of parameters, as you can see. It's highly interactive, and yeah, we're going to take a deeper dive later on. Oh, nice fractal. The second component is the ComplexMix. It takes two UV map outputs and an image to be mapped, and it performs operations between the two UV maps. The operations being adding, subtracting, multiplying, dividing, and power. There's also a lot of parameters that you can play with. And the +1 is an extra component, let's say. We are going to use that to create even more fractals, and it's going to be a bit more complicated. But yeah, it's going to be covered in a different section. So let's see a few examples now. I forgot to first mention that this toolkit called complexfunction.star is available to download in the description below for free, or you can donate. It includes a PDF documentation and some example projects, so you don't actually have to watch this full video if you want to dive right in, which I would suggest, because this is supposed to be kind of a playground. But yeah, if you want to know all the details and stuff, then keep watching. In this first example, I'm using 4 complex functions and just mapping a black and white ramp top. Here I'm using 14 different complex functions and controlling them all individually. In this next one, I'm taking a video source and UV mapping that, also doing a layer separation technique that I will maybe do a video about. This is a fractal-like thing using the ComplexIterator that I've yet to show, but it's going to be covered. And also, sorry for the frame drops, it only looks like that in OBS, unfortunately. Here I'm instancing points based on the UV map. I like how it kind of looks like a 3D structure, even though it's not. It's just complex math magic. Here I'm also just instancing geometry, to be more precise, using a job2 sub. And I think this is a complex tangent function being rotated, but we will take a closer look. And yeah, let's talk a bit about UV mapping basics next. Just a few words so that we are on the same page about UV maps. Here we have the standard 0 to 1 red and green UV map, with the red channel denoting the x coordinates and the green channel denoting the y coordinates. Here in the top right corner we have yellow, which is red and green 1, 1. Here in the middle we should have 0, 5, 0, 5 somewhere. So this is a nice and even normalized field of numbers, field of coordinates. We can then use the remap top to map any image based on these coordinates, and because this is the standard 0 to 1 UV map, it's gonna remap into the same image with this algorithm that it takes the first pixel of the UV map, looks at its coordinates. Here in the very bottom it should be 0, 0. Then it takes the first pixel of the image to be mapped and maps those pixels to the coordinates based on the UV map of the same pixel. So because it's 0, 0, it's going to map on the same spot. But as soon as we transform the UV map or do some maths, we can see how it reacts. Pakata 12 has a bunch of videos on this topic, so I'm going to link one of them. But basically what we're doing with the ComplexMath toolkit is that we are treating these coordinates as complex numbers and feeding them through complex functions. I would like to also mention the inspiration for this toolkit and the video. It's Ecstasy's video on complex numbers and warping, so basically the same topic we've been talking about. In his video he shows this collection of complex functions that someone from Shader Toy has implemented in GLSL, and you can write code and use these functions and see what happens. Oops. You also have a few parameters mapped, but once you wanna play around a bit more maybe, and so add more functions, and maybe you wanna translate them separately, so not together, right? Like now. It becomes a bit cumbersome to extend this code, and yeah, that's what my toolkit aims to solve. Okay, let's dive right in and have a closer look at the ComplexOp component. Right off the bat you can see that it has two outputs. The second output being the UV map, the generated UV map, and the first one being a mapped image. By default, if nothing is connected, we are mapping the standard 0 to 1 UV map, but I can also connect any top and it will be mapped according to the UV coordinates on the right. The first parameter needs a bit of an explanation. If I have this z/map parameter on, we are taking the input and mapping it according to the coordinates. But if I set it to z, suddenly we are taking the input as the operand of the function. This I can show you better maybe if I connect another UV map here. Let's make this square root. And this is off, so we are taking the first UV output as the operand. I will show you in code what's happening. First we have the square root, which has the standard 0 to 1 value set, which I denote with z here. Then we are connecting it to the input of the inverse function with the z/map in off. So that means the operand of the inverse function, which is the second box, becomes the output of the first ComplexOp. Like this, you can chain functions infinitely, and it will be very useful when we are doing fractals with this toolkit. Let's reset and move on with the other parameters. Some of the functions have additional parameters enabled. For example, the logarithm. It's by default the e, the base is the e, but I can change the base with the slider. Also with the complex power I can change the power or even more. And I can also output a constant value on all the pixels and all the coordinates. The center button does what it says. It centers the UV map. If I turn this off, you can see it's shifted, but what it does basically, it's just a shortcut doing some zooming out and some translation. Resetting those as well. You can rotate the UV map, and what it does is it rotates the value set, the operand, before calling the complex function. You can also iterate multiple times with the same function. So if I choose like a cosine and iterate it, and also zoom out, we already have some kind of a fractal going on. The post rotates the coordinates after executing the complex functions, and we can also scale and translate after the fact. The mode parameter, which I'm going to now rename right before your eyes because I realized that it's better called extend to be more consistent with Touchdesigner's other components. So this extend is the same extend that you have on the remap or the transform top or the GLSL top. So it's no surprise if you're familiar with this word in Touchdesigner. And lastly, and this is my favorite, you can blend in the original the original image. If we, for example, map ramp, it shows best. Also, if we do maybe circular instead, let me pump this up. We can blend in the original image. I think this is one of the coolest parameters. And yeah, with that we covered ComplexOp. Let's take a look next at the ComplexMix. Let's go back to the nice red and green map and copy paste this to have another OP. Choose a different function and drop down a ComplexMix component. It has the same two outputs as the ComplexOp, so the first one a mapped output and the second one only the UV coordinates. So what the ComplexMix does is that it takes two UV map outputs on its second and third input and performs operations between them. So you can add, subtract the functions, multiply them, divide, raise one on the power of the other and the other way around. You can also just choose one or the other. You also have this weighting switch with which you can essentially blend between the two functions. Let's see if we do it with divide, what happens. It's all about experimentation, so yeah, you need to check. Otherwise you don't know, because it's complex. Alright, you also have a mix, scale, and a mix translate, as well as rotation. The first input is again an image. It expects an image to be mapped, and you have the same mode, which I'm going to now rename to extend here as well. And you can blend in the original image again. So what's fun about this whole thing is that I can put down a lot of these boxes and play around, create some weird mixtures. So let's see, I now put down this inverse and connect the UV output to another ComplexMix. And map the ramp according to this. Let me pump this up. We can then just play around, and you will see that there's a lot to explore here. Before talking about the third component in the toolkit, ComplexIterator, let's see a few examples. Here I have 4 complex functions generating this pattern. A polar, which does this anti-clockwork motion. An arcus tangent, which is responsible for this wall, I would say. And 2 logarithms, which create these circular patterns. We add all these together with the complex mixes. Map a ramp. And also automate some parameters. So here we have the rotation. And is that it? No, we're only also modifying the mix translate, as you can see, and playing with the blend a bit. So let's see if we change the blend. Now we have more bands. You have to kind of watch out with the blend, because if you're translating this mix, if you take a look at the pixel values, we are now way beyond the original 0 to 1 UV map that we would expect. So if we blend in, we get a lot of crazy values between that are not so continuous. Let's take a look at the next one. In this example, I'm mapping a video which I got from Fractals. So this one, sorry for the choppiness. And I'm mixing 3 complex functions: an arcus cosine, a arcus tangent hyperbolic, I believe, and a sine. Adding these together also adding here. I can play with the weight, for example. If I have only this mix in the mix, we have this kind of a pattern, and this is a different kind of a pattern. What happens here is this 3D layer separation. I will probably also release this component as a standalone release, because I quite like it. And yeah, let's move on to the next one. Not the fractal, because I don't want to talk about the fractal now. Let's see some instancing. As you can see, this is a very simple network. Basically only using 2 complex OPs. In this case, I'm using the power and translating the mix to have the motion. Basically, that's what the motion does. And this is also why this modular approach is fun, because you can put any kind of top operators, you know, between. So this is without the blur. This is also cool, but with the blur it's somehow much cooler. I don't know what happens here exactly, but you can see the effect. Here I'm normalizing the values, so it fills out the space more. And yeah, you can see that we are just using this null top as the translate OP in the instance, and using the RGB values, well, the VP, not really, the RG values to translate the box instances. And as the values here change, the position of the boxes also change. In this next example, we are using a complex tangent function to generate this geometry. So we are using the chop to SOP, for which first we have to convert our top into chop, crop the full image, and sequence channels by name in the shuffle chop. We can then use this null as our chop to base, and here we already have this geometry. We don't need these actually, and I'm using the FractalsOp to make it fuzzy and audio active. And in the last example, I went kind of overboard. I wanted to see how far I can take it, but this one already kind of maxes out my 1080 GPU, because you have all these GLSL tops getting calculated on the GPU, and it quickly runs out of memory, sadly. But you can use 14 of these complex OPs and control them each by an LFO. So here, as you can see, I'm doing lots of rotation. I think basically that's all I do. I rotate all of them. No, here I also translate. What is this? Yeah, I need to translate yeah, I guess I don't remember what I did. But yeah, you can change these to your liking as much as you can, limited by your GPU. Of course, if you wanted better performance, you could implement all this in one GLSL top, but good luck and have fun doing that with 14 functions and controlling them individually and doing all the interface to the GLSL top, and basically experimenting that way. That's not fun, I would say. What I could do and what I would do is maybe play around with the toolkit if I wanted something like really complex like this. Play around with the toolkit, find what I want, and then later move on to a single GLSL top approach. But you can get really cool stuff with much fewer functions. So this is really just to demonstrate the limits. We finally arrive at the topic of fractals and the last component, the ComplexIterator. But before that, let's take a look at the original approach from Extas in a single GLSL component. So the equation for a Mandelbrot fractal is the square function plus a constant. In this case, we can take the original 0 to 1 standard UV as the constant, which would be this in this case, and iterate it multiple times, so increasing the iteration, the number of calls of the same equation. You can already see some fractal thing going on, which is nice. Let's now implement the same thing using the ComplexIterator from the toolkit. Let's start with a manual approach, not with the ComplexIterator, but how you would do this if you didn't have the ComplexIterator, which will do all the hard work for you. So we start with a ComplexOp of a C-square, and we need another one. This will be a standard UV image, also centered, both of them. Then we add them together as per the equation and iterate them. So basically copy and paste. Let the operand of the C-square be the result of the previous iteration. We also set this then to off. And we also need to be aware that because these are centered and the result is also quote-unquote centered, this operation doesn't have to be centered again. We then copy and paste this several times. Let's do a few to start seeing. Yeah, I think we can already see our Mandelbrot fractal kind of shaping up. Let's do one more. Oops. Yeah. So the ComplexIterator's job is to do all this for you, so you don't have to waste your time copy and pasting. And also, if you maybe want to control some parameters together in all the iterations, it would be yeah, a lot of work to bind all those. So let's see how the ComplexIterator can help us. So the ComplexIterator expects references to these components, so we can drag and drop them there. We will map this image, so connect it to the input. And the outputs are again the first one the mapped image, and the second one the UV coordinates. So if I click on reinit here, which you need to do whenever you initialize this ComplexIterator, after a bit of computing, here is the fractal. So what happens inside is that you have copies of the same OPs in here many times, and if I increase the number of iterations, it will put down more and connect them accordingly. So the OP1 in Z-1, kind of a cryptic parameter, but what it does is it performs the chaining of the functions. So when we connected the output of the previous iteration to the input of the C-square, this needs to be done here with this. As you can see, it does this connection for all the iterations. And the OP2 in Z-1 does the same with the other operator. The bind parameters do exactly what you would expect them to do. They bind the original component parameters to the copies inside the ComplexIterator. So if I do rotation here or translation, it is mirrored inside the copies. So here we have the translation that I just did. If I turn this off, it resets to the original values when it was created. Also the same with the operators. I can bind them. Here you can see it references the original component. Also with the second one I can do this. Yeah, so this ComplexIterator component can be sometimes a bit buggy. Maybe, I don't know, if you see any problems, just let me know. The reinit button is your friend. And yeah, have fun with it. Yeah, and I have to show you a example. So here it is. We basically have kind of a Mandelbrot set, but not really. Instead of a C-square, we have a power with 6.43 as the, what is it called actually? Well, the power. And instead of a standard UV image, we have a constant complex number minus 1.3 minus I times 1.2. And instead of adding them together, we raise the power to this constant complex number. And we also do some weighting between the two functions. So we basically multiply this by 0.137 and multiply this by 1 minus this amount. I can also play with this and see what happens, but yeah, it's kinda unpredictable. Although it looks nice like this. And on the ComplexIterator, we have all of the parameters bound. Especially important on the mix, because that's what we are controlling with this LFO. We are only controlling the transformation of the of the result of this. And also we rotate it by a bit. We could also control this, it would also look cool. Yeah, that's what the ComplexIterator does. You can play around, find new combinations, see which translations work, and just in general have a good time with it. That concludes my first tutorial and the release of ComplexFunction.store. I hope you learned something and didn't fall asleep. I know there's a lot to be improved. You can find the download in the description below. You can find me on Instagram at function.str. Please send me a message if you have any inputs or complaints. And also please tag me if you happen to use it in one of your creations. I would be very curious to see what you can come up with, and yeah, see you next time, maybe.